Today we're going to be continuing our work in Chapter 6, specifically focusing on Section 6.4, but I do have a startup for you to try here. So if you will try it, pause the video, try it, and then check your answers. So for this one, I would suggest setting up a right triangle. It doesn't really matter which direction the triangles turn. Just set this up, pick one angle, one of your acute angles to be your theta, and then in relation to that, cosine is adjacent over hypotenuse. So my adjacent side, I'm going to put 5, and my hypotenuse is 13 because that's the one opposite the right angle. So then we'd use Pythagorean theorem to find our missing side, which would be this 12 here. So if you plug that in, be sure you put the 13 in on the side by itself because that's the hypotenuse, and you'll end up with b equals 12. So from here, you can set up the relationship. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. And then these three, you'll just do the reciprocals of these original three. Keep in mind it's in the third quadrant. So in the third quadrant, everything is negative except for tangent and cotangent. Okay, so in section 6.4, we're going to look once again at inverse trig functions, except this time we're going to be looking at them in relation to right triangles. So just as a reminder, when we studied inverse sine, cosine, and tangent before, we talked about how we had to restrict the domain in order for it to pass the horizontal line test and be one-to-one and therefore have an inverse. So those same domain restrictions apply here. If we're talking about sine, we have to restrict it to be in between negative pi over 2 and positive pi over 2, which is still going to be the fourth and first quadrants here. For cosine, we're going to restrict it to be in between 0 and pi, so the first and second quadrants. And then for tangent, we're going to restrict it to be in between negative pi over 2 and positive pi over 2. One difference here with sine and tangent is, if you notice, these have the equals. This one does not, because tangent cannot, we can't do the tangent at negative pi over 2 or positive pi over 2. It's undefined at those values. Okay, so we know what our inverse notation looks like. Basically, is what that is saying. Okay, so here's our domain and range. So if we're talking about these restrictions we placed, they become the range of the inverse function. So they were the domain restrictions for the regular sine function, but they're going to be the range for the inverse function. Same thing for cosine and for tangent. Those will become the ranges. The domain for inverse sine is from -1 to 1. Same for inverse cosine, and then all real numbers for inverse tangent. And these we talked about back in section 5.5. If you need a refresher on that, you're welcome to pull that video back up and look at the details behind why these are the way that they are. Okay, so just kind of to get us started here, if I'm looking for inverse sine of the square root of 3 over 2, this asks where or what is the location where sine is the square root of 3 over 2. And for sine, we said we're restricted to working between negative pi over 2 and positive pi over 2. So that's this part that goes around here. So this is the positive quadrant, and this will be our negative quadrant. So since I need a positive value, I'm going to be looking over here, and sine is positive square root of 3 over 2 here for pi over 3. So my answer is going to be pi over 3. For this one, I'm going to look and see where is cosine, -1/2. So for cosine, I look at these first and second quadrants. So for a negative, I'm going to look at the second quadrant. So cosine is -1/2 here at 2 pi over 3. And then inverse tangent is +1. Tangent is going to be +1 where our x and y values are the same. So that's going to be pi over 4. And again, for inverse tangent, we look at the fourth and first quadrant. Okay, so in this section, what we want to kind of expand to is actually being able to solve these problems that involve inverse sine and inverse tangent and inverse cosine. So first note, be sure your calculator's in degrees as we solve these triangles. It's really important that you have it set in degrees. And anytime you're solving for an angle, you're going to end up using inverse sine. So if you're solving for a side, you'll use just regular sine regular cosine, that sort of thing. But if you're solving for the angle, you're going to use inverse sine, inverse cosine, inverse tangent. So for this one, if I set this one up in relation to this theta here, if I'm trying to find this side, then this is going to be the opposite side, and this is going to be the hypotenuse. Okay, so if I set this up, I'm going to have the sine of theta equals the opposite side, which is 10, over the hypotenuse, which is 50. Okay, if I want theta by itself and I need to get rid of sine, the way that I'm going to do that, the process for doing that is I'm going to take the inverse sine of both sides. Because we remember that inverse sine and sine, when composed together, cancel each other out. Okay, so these are going to cancel, and I'm going to end up with theta equals, and then this is where I'm going to put this in my calculator. I'm going to do the inverse sine of 10 divided by 50, okay, and I'm going to get 11.54 degrees. So just watch your directions so that you understand how many decimal places around it too. And also, like I said, be sure that you're in degree mode. Okay, here I'm asking for you to set up 3 different ways to find theta. I think there's a homework problem similar to this. So I just wanted to go over. In relation to this, if you have all the sides, I could set this up using sine. So the sine of theta would be my opposite divided by my hypotenuse. So opposite hypotenuse. If I wanted to set up cosine, then cosine is going to be adjacent, which is 9 over hypotenuse, which is 15. And tangent is opposite over adjacent. So opposite and adjacent. So if I wanted to rewrite these, what's going to happen is this one's going to be the inverse sine of 12 over 15. This one will be the inverse cosine of 9 over 15. And this will be the inverse tangent of 12 over 9. So I could find theta either of these three ways, either by using the sine relationship, the cosine relationship, or the tangent relationship. And if I put these in the calculator, each one of these relationships will give me the same answer. So they're all going to give me theta. So here's an example of where we would use inverse sine on a word problem. So we've done some of these where we worked with angle of elevation and angle of depression and so forth. But in each of those cases, we were solving for a side. Here we're going to be solving for an angle. So it says a 40-foot ladder leans against a building. So here's our building. Again, I apologize that I have trouble drawing straight lines. We have our 40-foot ladder that's leaning against the building here. So this is our ladder. This is, hopefully the building is straight, and so it's going to form a right angle with the ground. If the base of the ladder is 6 feet from the base of the building, so here's the base of the ladder, here's the base of the building, so this is going to be 6 feet. What is the angle formed by the ladder, which is this part, and the building, which is this part? Okay, so a common mistake people make is they automatically think this is the angle that they're finding. You want to make sure that you find the angle that's described. So here it says, what is the angle formed by the ladder and the building? So that's going to be this angle up here. So in relation to this angle, I have my opposite side and I have my hypotenuse. So opposite and hypotenuse is going to be the sine function. Okay, so the sine of our angle is 6 over 40. So I want to solve for theta. I'm going to take the inverse sine of both sides. So theta, we know these cancel. So theta is going to be the inverse sine of 6 over 40, or 8.6 degrees. And again, just pay attention to what it's asking you to round to. Okay, so we're going to start solving some basic trig equations. And the thing we have to consider is on some occasions, there are going to be more than one answer. Okay, so if I look at this here, in this case, sine is one of the cases where we have to consider more than one answer. Because in this case, I'm looking for where sine is a positive value. So we know sine is positive here and also here. We're asked to find all angles of theta between 0 and 180. So basically for sine, for this one, I'm only going to be looking at 0 to 180. So I'm going to forget that the bottom part of this circle even exists. I'm just going to look at this top part here. Okay, so I'm going to there's a place somewhere over here where sine is 0.4, but there's also some place over here where sine is 0.4. So what I'm going to do is, I know to get rid of sine, I'm going to have to do inverse sine. Okay, we know that those are going to cancel. So the inverse sine of 0.4 is going to give me 23.6 degrees. Okay, so that is this angle over here. That's 23.6. But like I said, there's one over here that we also need to find as well. So the way that I'm going to find that, because this angle and this angle are actually identical, is I'm going to do, in the first quadrant, it's the angle I get, but in the second quadrant, I'm going to say 180 minus the 23.6. And that's going to give me 156.4 degrees. So basically, both 23.6 and 156.4, the sine of those two angles is going to give me a value of 0.4. Okay, let's look at cosine. Again, because of our directions, we're only giving answers between 0 and 180. So that means the bottom part of our circle doesn't exist. But when I look at these two quadrants here, cosine is only positive in the first quadrant. So I don't need to give a second quadrant angle for cosine. I'll only have to do that for sine. And one side note, one reason we're only looking at angles between 0 and 180 is because we're also working with triangles in this section, and the sum of the angles of a triangle is 180. So that's one reason we're restricting ourselves to being between 0 and 180. So here, if I look at taking the inverse cosine of both sides, because that's what's going to cancel. That's what's going to cancel off here. So theta is going to be the inverse cosine of 0.44 degrees. Okay, so this angle over here is 66.4. I don't need to consider the second quadrant because cosine is negative in the second quadrant, and we were specifically looking for the positive cosine value. Okay, here are a few for you to practice with. So I would like for you to pause this, try these four, see if you get them right, and hopefully you do, and then we'll move on from there. Okay, so for all of these, we're only looking at 0 to 180. So we're, again, disregarding the bottom part of our circle here. So I'm looking for where cosine is negative. So if I look at these two quadrants that are left, cosine is negative here in the second quadrant. So I need to keep that in mind when I do this problem. So I'm going to only be looking for cosine for that one angle. So I'm going to do the inverse cosine so theta is going to be 113.6 degrees. Okay, moving on to our next one here. I'm looking for tangent, and I'm looking for a positive value. So looking at these, tangent, when I do inverse tangent, I'm restricted to these two quadrants here. So because of that, this is the only one that I'm going to be using here. So I don't have to worry about the second angle for tangent either. So this will be a first quadrant angle. So I'm going to do the inverse tangent of the tangent of theta equals the inverse tangent of 5. So I'm basically just taking the inverse tangent of each side. These are going to cancel, so I get theta equals the inverse tangent of 5. So when I put that in my calculator, I get 78.7, and that is our first quadrant angle there. Okay, moving on to the next one. Here we have sine of theta equals -6/7. Well, when I look at this automatically, I have a little bit of a problem because sine is negative in these two quadrants, but we're not using these two quadrants. So this is going to be a no solution problem. Okay, so it's undefined or no solution that falls within the interval that they've specified. Now, there are solutions to this, just not between 0 and 180. Okay, moving on to this next one. If I look at this one, sine is positive in both the first and the second quadrant. So I need to find two angles for this one. So I'm going to take the inverse sine of both sides to start with. As you get used to this process, you can definitely shortcut this first step. I'm just writing it out so that we can kind of get it in our mind what we're doing. We're taking the inverse sine of both sides. These cancel. So I have inverse sine of 2/3, which is 41.8. So 41.8 degrees. That is my first quadrant angle. To get my second quadrant angle, I'm going to have to do 180 degrees minus the 41.8 that I just found, and that's going to give me my second angle, 138.2 degrees. So if you're not sure and you want to check your work, all you really have to do is take the sine of 41.8 and make sure it's 2/3, and take the sine of 138.2 and make sure the sine of it is 2/3. So they should both check for you. Okay, so here's one where we're going to work with composing different trig functions and their inverses. So what we're going to do with these is I wanted you to think of it as a two-step process. The first part is going to be step 1, and you're going to build your triangle. So I'm going to use this inside part to build my triangle. And then the outside part, this whole part here, is actually going to be what gives me my answer. Okay, so the first thing that I want to do is use this inside part to build my triangle. So I'm going to draw a right triangle, and I'm going to designate an angle here. So the inverse sine is 3/5. So sine we know is opposite over hypotenuse. So in relation to this angle, opposite hypotenuse, and we don't know our other side. So we want to use Pythagorean theorem. Some of you may recognize this as a 3-4-5 triangle. If not, then go through the Pythagorean theorem. So this side will let be x. So x squared plus 3 squared equals 5 squared. So we get x squared is 16. We don't really have to worry about the negative because we aren't going to have a negative that's the length of a side of a triangle. So this side then is going to be 4. Okay, so we've used this part to build our triangle. So now I'm going to just recopy this, but in the place of all this, I'm going to put theta. Okay, so now I just need to look at my triangle and say, what is the cosine of theta? Well, cosine is adjacent, so that's 4, over hypotenuse, which is 5. And so my answer is 4/5. So again, two-step process, build the triangle using the inside, and then answer the question for the outside part. Okay, so here's one. We'll go through it again. If you feel comfortable and want to pause it and try it yourself, by all means do that. Okay, so here's our right triangle. We'll put our angle. Tangent is opposite over adjacent. So it turns out this one is also another 3, 4, 5 triangle. If I did my Pythagorean theorem, I'd find out that this side is 5 as well. Okay, so all of this I'm going to replace with theta. So I need the cosine of theta. So cosine is adjacent, which is 3, over hypotenuse, which is 5. So my answer would be 3/5. Okay, here's one for you to practice. Build your triangle, then answer your question. Okay, on this one, when we build the triangle, okay, our opposite, because this is opposite over adjacent, opposite is 12, adjacent is 5, so we don't know what this side is. So we're going to have 5 squared plus 12 squared equals x squared. So x squared is going to be 169. Take the square root of both sides. So x is going to be 13. And you may have recognized that as another one of those special triangles that we work with a lot. Okay, so we can replace all of this now with theta. So cosine of theta is going to be adjacent over hypotenuse. So adjacent is 5, hypotenuse is 13. It just so happened that the problems we were working with, cosine was the function that was out here. There's nothing special about that. I could have been asked to find the sine of inverse tangent of 12 over 5, and I would do that the same way. I would use the inside to build the triangle, and then for the sine of theta, if I replace all this with theta, then sine of theta would be opposite over hypotenuse, so it would be 12 over 13. Okay, so here's a word problem similar to one you're going to see on your homework. We've got a 680-foot rope. So here's our rope. Anchors a hot air balloon as shown in the figure above. We want to first of all express the angle theta as a function of the height of the balloon. So when it says as a function of the height, basically you're going to be giving an equation that still has h in it, is what it's asking for there. So if we move to looking at this where I have a little bit more room, we want to set this up. So in relation to theta, we have the opposite and the hypotenuse. So I'm going to set it up as the sine of theta equals opposite over hypotenuse. I want to get theta by itself in order to express theta as a function of h. So I'm going to take the inverse sine of both sides. This is going to cancel, and so I'm going to get theta equals the inverse sine of h over 680. And so that's what it means when it says express the angle theta as a function of the height h. So it's an expression like this. Part B, find the angle theta if the balloon is 600 feet high. Well, we've already done the work here. So all we really have to do is to plug into that. For that height. So if our height is 640, we'll do the inverse sine and we'll get 70.25. And again, just watch your directions on the rounding. Oh, it says round to 1 decimal place. I'm not even reading my own directions. So 70.3 degrees. Okay, here are a few for you to practice with what we've done today on solving trig equations. These are on this interval from 0 to 180. So we're just looking at these upper two quadrants here. So let's try these and make sure that you're good with them before we wrap up for today. Okay, on the first one here, we're looking for where sine is square root of 3 over 2. We already said we're going to disregard this bottom part. So there's actually two places where sine is square root of 3 over 2. So that's going to be pi over 3 in the first quadrant. And it's also going to be 2 pi over 3 in the second quadrant. But because it's asking specifically for degrees, that's going to be 60 degrees. And then for the second quadrant, we're going to do 180 minus 60. So that's going to be 120. So those are the two angles in degrees where the sine of those angles will be square root of 3 over 2. Here for cosine, I'm looking for where cosine is -1 specifically in this interval. So cosine is -1 over here at 180 degrees. Sine, if I'm looking for where sine is negative, sine isn't negative anywhere in the specified interval. So this one would be no solution. And then tangent is +1. If I'm only using these two quadrants, then tangent is +1 here in the first quadrant, and that would be the pi over 4s or the 45-degree angles. So remember, the only ones you have to worry about finding that second angle for when you're restricted to 0 to 180 is the sine function. Cosine and tangent, you just find the one answer. Okay, here I've changed the interval from 0, instead of 0 to 180, it's 0 to 2 pi. So kind of by the same rationale, we basically solved that already with these. So I'm going to go back here. This one, because if we were looking at 0 to 2 pi instead of 0 to 180, then my answers would be here in radians. So it would be pi over 3 and 2 pi over 3. This one, instead of 180, is going to be pi. This one would still have no solution, and this one would be pi over 4. So basically, we had already solved them on the interval from 0 to 2 pi. Okay, and that finishes up section 6.4. We have 2 sections in chapter 6 remaining and a couple sections in chapter 7, and then that'll finish up the course for us. So it's coming to an end pretty quickly. Be sure you're staying on top of everything, and let me know if you have any questions. I hope you have a great day.